Well, hey, everybody, and welcome. Climate change. Is it real? Is it fake? What are we going to do about it? This is going to be the topic of today's conversation. My name is Ryan Pauly. This is the weekly show where I challenge you to think deeper about Christianity and the Christian worldview, the issues that we have to deal with. And oftentimes it's arguments for God's existence and looking at reasons to believe in God, but also it is issues and how do we live as Christians in our culture. And one of those controversial issues is climate change. So that is going to be the topic. Thank you so much for joining. If you're watching live, you can always send in those questions. We'll get to them throughout the conversation. If you're watching after the fact, know that this is a live show as well. So joining me to have a conversation on this book is astronomer Dr. Hugh Ross. He is the founder and president of Reasons to Believe, a ministry dedicated to integrating science and faith. His books include Weathering Climate Change, Why the Universe is the Way It Is, Navigating Genesis, as well as many others. And the first time that he joined my show was discussing his book, Always Be Ready. And so, Dr. Ross, thank you so much for coming on again.
You're very welcome.
Absolutely. I love, obviously, I always say this. I love the work of your organization, Reasons to Believe. I think I had all of your scholars on my show at least once. I think Ken Samples twice and Zwerig twice, and now this is your second time, and even AJ Roberts and Krista Bontrager, and just all the wonderful resources that you have at your ministry. So, oh, and I can't forget Fuzz Rana. He's coming on twice as well. So thank you so much for just the work that you do, because as I frequently say on my show, science is one of the difficult issues that people have of integrating science and faith, as well as whenever I reach out to my listeners and say, what topics do you want to hear? Generally, it's always cover more science, because I think this is one of the big issues. So maybe we'll start with that and say, what is it about science and religion, science and faith, that creates a lot of problems for people?
Well, God's given us two books of revelation, the book of nature and the book of scripture. So I don't really see it as a problem, but what's interesting is the book of scripture is 66 books. The book of nature is dozens of different subdisciplines of science. And I think the challenge is integrating them all. Just
Yeah.
like it's a challenge to integrate Hebrews and Romans with Leviticus, likewise it's a challenge to integrate astrophysics with geophysics, with biochemistry.
Yeah. So that maybe kind of leads into the first objection. Now, I know oftentimes when someone writes a book, the book we're discussing here is your book, Weathering Climate Change, A Fresh Approach. Often the question is, well, why did you write this book? But I maybe want to first present an objection, because when I posted on my YouTube channel that I was going to have you come on to discuss your new book, a skeptic wrote and said, next, why don't you have a dentist come on and talk about evolution? And so kind of this objection of like, Dr. Ross, you're a phenomenal astronomer, but you're not a climatologist. Why are you writing a book on climate change?
Well, what we do at Reasons to Believe is we pull top academics out of academia and bring them here to Reasons to Believe, where we set them free to do interdisciplinary research. And having read the climatology literature, I notice that most people are writing from a narrow subdiscipline. I make a point in the book. Astrophysics, especially solar physics and geophysics, are huge factors in being able to understand climate change. So, as an astrophysicist, as one who's studied geophysics and geology and paleontology and atmospheric physics as well, I think I am qualified to speak and write in this subject. But I also make it a point in this book to include material on climatology that you're not likely to see in the climatology literature. And already I've gotten some really good feedback from people who are specialists in climatology telling me how much they appreciate the interdisciplinary approach that I took.
Well, that's what's going to be my next question that I was curious about, is because often it's kind of this kind of poisoning the well, or this genetic fallacy of, well, you're not a climatologist, therefore you have no authority to speak on these things. Not realizing that a scientist can read and produce true information, even if it's slightly outside their area. So you mentioned there briefly, could you maybe explain a little bit more of what do climatologists have to say with your work here?
Well, I think they're impressed, number one, of how we're not just looking at carbon dioxide, we're looking at multiple factors that can warm the climate. We give a historical approach, looking not just at the climate of the past 100 years, we're looking at the climate of the past 4 billion years. and giving a detailed look at what's going on in the past 25,000 years. Then also looking at the climate of the sun and how that can impact the climate of the earth. I waited to write the book until we had really reliable temperature records for the past 10,000 years. That's new. 2 years ago, that wasn't the case. Now we have that thanks to a detailed study of 74 different temperature proxies from all over the world. In the past, people were relying on just one or two temperature proxies, and now we got something I think we can really trust, and it's helping to settle a lot of the debate issues.
Okay, so we've been hearing a lot about global warming and climate change for many years. But here you just mentioned, I want to make sure I understood that kind of within the last 2 years have we had really good information. So what were all of the conversations about back in the 90s and even before that if the information was not maybe as good? Was it accurate back then or how has it changed in the last maybe 20 or 30 years?
Well, what we now know is that the climate of the past 9,500 years is far more stable than what we previously thought. The global mean temperature has not changed by more than plus or minus 0.65 degrees. The old data said plus or minus 2 degrees. It's now plus or minus 0.65 degrees. The other thing we notice is that the global mean temperature has very gradually declined from a maximum 8,700 years ago to a minimum around 1950. And then from 1950 to where we are today, it's gone back up to the maximum of 8,700 years ago. In the past, we couldn't actually see those kinds of details. Now we can. And also recognize that the natural contributions to the global mean temperature are actually cooling the planet. Human activity is warming the planet, the natural cycles are cooling the planet, and for 9,500 years, the human activity has almost perfectly counterbalanced the natural cooling activities that have been going on. However, in the last 70 years, we are seeing a trend where that could go out of balance.
Okay, so good. So we're going to look at some more of this history as we get into your book, but maybe let's just start with the most foundational question of climate change. So you're talking about climate's changing. So climate change is real then.
Well, climate instability is the norm for planet Earth. That's one reason why I begin the book with looking at the whole history of the Earth, basically making the point the norm is climate instability. The exception is the extreme climate stability we've had for the past 9,500 years. And most of the book is about the fine-tuning design that's needed to open up this tiny window of extreme climate instability in the midst of an ice age cycle. The global mean climate is most unstable when you're in an ice age cycle. And I make the point early in the book that you have to be in an ice age cycle to have any potential of feeding billions of human beings. It's thanks to ice left over from the last ice age that we got water to irrigate the great agricultural plains of the earth. It's thanks to the rapid retreat of ice that took place at the end of the last ice age that there were volcanic eruptions around the world that fertilized the great agricultural plains. That's just 2 of 15 benefits we get from living in an ice age cycle. But what typifies an ice age cycle is the global mean temperature bouncing up and down by 12 degrees centigrade, that's 20 degrees Fahrenheit, on timescales of 2 or 3 centuries, which explains why humans living towards the end of the last ice age could not launch civilization. The climate was radically unstable and simply made it impossible to scale up any kind of agricultural activity. But beginning with climate stability that began around 11,000 years ago, that enabled humans to begin to launch large-scale civilization, and about 9,500 years ago, it went extremely stable. But it's the result of an amazing combination of dozens of natural things happen to be fine-tuned just the right way in combination with the launch of human civilization happening at just the right pace to counterbalance the cooling activity. I mean, if it wasn't for human activity, we'd be deep in an ice age right now. And so the launch of human civilization prevented a rapid drop into an ice age. But I do agree with climatologists that we're seeing over the past 70 years is suddenly taking that picture out of balance.
Hmm.
However, I end the book by making the point there are steps we can take where we can stabilize the climate and at the same time boost the world economy, and especially for the benefit of the poor, and also benefit the world's ecosystems. There are dozens of win-win-win solutions. And so, and my complaint about the global warming debate is you've got people, especially politicians, making the claim that we need to institute draconian economic sacrifices in order to stabilize the climate. And in my opinion, they're ignoring a key biblical principle. We human beings are fundamentally selfish, and trying to pass laws to force us to drop our standard of living by a factor of 2 or 3 times, that's not going to work. We have to give people an economic incentive. And I
Yeah.
also argue that's consistent with a second biblical principle. We are to manage the planet's resources for our benefit and the benefit of all other life. That implies there will be win-win solutions.
Well, I think that idea of us being selfish is often one that our culture is not having on the front of their mind that leads to a lot of issues around the world or even in our culture. Now, man, you mentioned so much about the Ice Age cycle that I have questions about, but kind of more leading back to this. I guess the one question that came in the live chat was whether you are a young Earth creationist or old Earth, and so I'm curious of um, is there any rejection of climatology because it's talking about these ice age cycles that have gone on for millions of years or 9,000 years when the earth hasn't been around that long, and so obviously our science is flawed? Or how does the theology and the doctrine of creation kind of play into someone's understanding and application when it comes to climate change?
While my scientific peers who are not Christians are very critical of young earth creationists because of what they see as their tendency to dismiss the scientific data. And so, as I engage young earth creationists, I make the point that God has given us two books, the book of nature and the book of scripture. And to be sure, science is not the same thing as the book of nature. It's our interpretation of the book of nature,
Mm-hmm.
just like theology is our interpretation of the book of scripture. And I see commands in the Bible that we're to carefully integrate what God has revealed in the book of nature with the book of scripture. So if we see something that appears to be contradictory, that should drive us to a deeper study, because God has told us that both books are a reliable revelation from Him. It's impossible for Him to lie or deceive. And so rather than reject the Bible or reject nature, I think we as Christians are committed to seek for coherence in what God has revealed in both books.
Yeah. And I think that's good. And I think this is kind of you're presenting the case of why Christians should care. And we're definitely going to get to the application in the end and the steps that you have proposed and what we can do to help. It's kind of interesting, though, because you said that it was because of human activity that we have kept ourselves from going into, I guess, another ice age, correct? If it wasn't because of the human activity. So I guess, there is some advantage to us driving our cars and producing what we do, but now we've thrown it off balance, and that's the problem, right?
Well, that's the problem, because in the last 70 years, the advance of human civilization and technology has risen exponentially. And so we're in a very different state than we were, say, 200 years ago or 1,000 years ago, where civilization was advancing at a relatively slow pace. It's now advancing at a rapid pace. On the other hand, I fully argue that there are resources that are at our fingertips whereby we can continue the acceleration of our economy and technology while we do the right thing in stabilizing the climate and making sure the ecosystems are healthy.
Yeah. So that's good. And this idea of biblical stewardship, of this is God's creation. And so we have to take this seriously and I think understand this issue. And so how how serious is this issue? I mean, you hear people that I mean, I've heard statements like, if we don't make a drastic change, Florida's underwater in the next 10 years, kind of statements. And then other people that says, oh, no, it's not going to be for a long time. So in your research, what have you kind of found? How serious is this issue? Granted, we don't take kind of these drastic measures if we kind of stay on the same path that we're on now.
While we stay on exactly the same path we're on now, we are in big trouble because, we've seen a 1 degree centigrade rise in the past 70 years. If we continue on the path that we're on, it's going to go up another degree, another 2 degrees. If it goes up another 2 degrees centigrade, then we will melt the polar ice cap. And if you melt the polar ice cap, instead of that polar ice reflecting sunlight with 60% efficiency, open ocean Arctic liquid water will reflect it with only 6% efficiency. All that extra heat being absorbed in the Arctic is going to create water vapor, and that water vapor is going to fall as snow on Siberia and Canada. And that's what we see in the ice age cycle. Global warming always brings on global cooling. You dump a lot more snow over Canada and Siberia, very quickly they become covered with thousands of feet of ice. That cools down the whole planet, and you've got 90,000 years, 23% of the planet covered with thousands of feet of ice. So if we want to prevent that, we need to preserve the Arctic ice cap, and that requires stabilizing the climate.
So I guess that's one thing that I maybe I've had a hard time understanding, and because I think if our climate is getting warmer that causes the ice caps to melt, why would it still be snowing over Canada? Wouldn't the snow melt there as well? To why would the melting ice caps? You think if you're creating all this humidity as you talked about, water vapor, then it would stay as like a tropical island, not create more snow and drive us into another ice age.
Well, I was born, raised, and educated in Canada, and I can tell you when you get into central Canada and northern Canada, the winters are like 60, 70 below zero. And yes, if we continue global warming, it's only going to be 40 below zero, 50 or 60 below zero. It's still going to be plenty cold enough for snow to accumulate there. The only reason why Canada is not covered with thousands of feet of ice today, most of Canada is a virtual desert. It simply doesn't get enough snowfall in the wintertime for that snow to accumulate. The summer temperatures will melt it away. But if you double or triple the precipitation over Canada and Siberia and Northern Europe, that snow will accumulate and
Hmm.
will form ice. And you literally get thousands of feet of ice in just a few centuries.
Wow. Yeah, I guess simple little information like below 60 below to 40 below. Yeah, that makes a lot of sense. Now, would that then? So, is what you're saying is then that additional snowfall will then drive the ice age to where then now there's massive cooling, and that would start cooling places that normally don't get snow as well.
That's correct. You get global cooling because the last ice age covered 55% of North America with thousands of feet of ice.
Hmm.
We have literally penetrated all the way down to Southern California. In the wintertime, San Diego was frozen over. And then you could go to most of Europe was covered with ice. Siberia was covered with ice. Uh, you know, Tasmania in Australia was covered over with ice. So when you get that much ice coverage, it has a global cooling effect, and it literally takes tens of thousands of years to recover.
Hmm.
I mean, there are natural cycles that will warm the planet and cool the planet. Right now, for example, the rotation axis of the Earth is tilting back towards 22 degrees. When it tilts back to 22, the planet cools. When it tilts towards 24, the planet warms. And so right now it's going back towards 22. So that's going to cool down our planet. The shape of our orbit around the Earth is also working to cool the planet. But about every 100,000 years, those cycles reverse and they warm the planet. So you will come out of an ice age, but you got to wait a long time.
So what you've been saying here seems like there are quite a lot of factors that go into the conversation and into the actual changing of our climate, from the tilt of the Earth to the ice caps to so much. You mentioned at the very beginning that a lot of the climatologists are happy about the fact that you don't simply just mention CO2. Why is it that that is something that is so focused on, is CO2 and kind of, I guess, carbon emissions? Is that what you're talking about? Versus all these other factors that lead into this climate stability?
Well, I think CO2 gets a lot of attention. Number one, it is one of the primary greenhouse gases that's warming the planet, and it's also the most straightforward one to deal with. Just stop fossil fuel burning, you'll bring down the carbon dioxide emissions. But I argue in the book that that won't help. You also got to find a way to deal with the methane emissions, the nitrous oxide emissions, the hydrochlorofluorocarbon emissions. And one thing that's really been overlooked is the deposition of black carbon soot. So, for example, all the coal burning that's going on in China and India, the black carbon soot from that doesn't land so much in India and China, it gets deposited in Canada. I mean, Canada's warming up 5 times faster than the rest of the world on average, but there's new research showing that the black carbon soot is making a bigger contribution than the carbon dioxide.
So, okay, man, there's so much that goes into this. That is why, again, the focus then of your book, it seems, is focusing on this extreme, rare climate stability that we shouldn't expect to see what I guess we have seen for so long. This book is kind of an addition on to a previous book that you wrote, like Improbable Planet. So how is it then, maybe go into some of those details that really points to design? You've talked about some of the just right conditions. What is it about climate change that really points to a designer creating this world to provide this stable environment for us to live and thrive?
Well, first of all, I talk about why we're in an ice age cycle at all. Because if you look at what's happening with the physics of the sun is warmer today than it's ever been in the entire history of life on planet Earth. And therefore, we shouldn't have any ice at all. For 90% of Earth's history, there's been no ice, yet the sun is warmer than it's ever been, and we shouldn't have any ice. And so, how is it that we have all this ice when the sun is luminous as it is right now? And I make the point that it's thanks to a giant asteroid that struck off the south tip of South America. That happened 2.58 million years ago, and it basically threw up an aerosol cloud around the Earth that was so dense and lasted for so long it cooled the planet to enable a lot more ice to accumulate over Greenland, over Antarctica, and especially over the Tibetan Plateau. The Tibetan Plateau actually has more ice in it right now than what you see in the Arctic. And because it's so close to the equator, it reflects sunlight 4 times more efficiently than sunlight reflecting off Greenland or Antarctica. So that had a major cooling effect. That's why we're in an ice age cycle right now. However, it launched an ice age cycle that was driven by the changing tilt of Earth's rotation axis. That has a period of 41,000 years. With a 41,000 year period, your warm interglacials are only going to last 2 or 3,000 years. That's way too little time to launch global high technology civilization. And I argue from a Christian perspective, that's necessary to get the good news of salvation through Jesus Christ out to all the people groups of the world. It was God's intent all along that we build, launch, and develop global high technology civilization, which requires a longer interglacial. But there's another big asteroid that struck in the South China Sea in Laos about 800,000 years ago. And that was one of 15 factors that combined work together to change the ice age cycle from 41,000 years to 100,000 years, which meant it was now possible to have a 10,000 year long warm interglacial. But the biggest contributor of all was another giant asteroid, about 2 kilometers in diameter, that struck in northwest Greenland only 12,800 years ago. And the crater of that asteroid collision was discovered only a couple of years ago, and almost by accident, one of those NASA aircraft was flying over northwest Greenland and happened to have their deep ice penetrating radar on, and they found this crater under 3,000 feet of ice. And the crater was 32 kilometers in diameter. They said that has to be a giant asteroid. Well, what that asteroid did is it stopped the global mean temperature from going up to its normal maximum. Typically, what happens when these natural cycles begin to warm, it drives the global mean temperature 2 degrees centigrade above where we are now, melts the polar ice cap, and drives us quickly back into an ice age. That did not happen because this asteroid struck 12,800 years ago, and for 1,200 years cooled the entire planet by 10 degrees centigrade. And that stopped us from going up to the normal maximum. It also brought about a short period of climate stability. And with that short period, humans launched civilization. And that was also the time when the warming cycles, natural warming cycles tilted and became cooling. But that's exactly what happened. The cooling now got counterbalanced by the continuing growth of human civilization. The only time in the entire ice age cycle we've had this extreme climate stability has been the past 9,500 years, and that wouldn't have happened without these 3 asteroids hitting the Earth at just the right time, at just the right place, where the asteroids have exactly the right composition. These need to be stainless steel. 2 of them have to be stainless steel asteroids, and 1 of them has to be a carbonaceous comet asteroid striking the Earth. So it adds up to a whole lot of fine tuning. And what really amazes me as an astronomer, this period of 9,500 years of extreme climate stability perfectly overlaps a period when our Milky Way galaxy has not had any supernova eruptions within 5,000 light years of the Earth. That's never happened before, but if you want global high technology civilization, you don't want any supernova eruptions inside of 5,000 light years. And that's just one of over a dozen narrow time windows that miraculously overlap one another in a perfect way to give us this period of extreme climate stability. Bottom line, we not only need to see this as fine tuning, we need to see this as a miraculous gift from God and ask ourselves the question, why did he give us this amazing gift?
So you're saying we didn't just get really lucky?
We didn't, no, it's not just luck.
My goodness, wow. My mind is blown. I don't even know what to ask right now. There's just so many questions of, first of all, I didn't know there were stainless steel asteroids. Is it, you said 2 of them have to be stainless steel?
Yes. Yeah, there's actually
Metal is accumulating out in outer space?
well, there's this idea in the textbooks that humans didn't launch metallurgy until 3 or 4,000 years ago. The truth is that Native Americans in Canada were mining this asteroid 11,000 years ago, taking pieces of the asteroid and forging them into stainless steel tools. Because the
Wow.
grade of stainless steel you see in these asteroids is actually better than what we manufacture in steel factories today.
It's like Thor's hammer, right? It's like this like super metal that can do stuff. Wow.
Yeah.
Okay, so maybe the next question that comes to my mind is, okay, you talk about God creating this perfect ice age cycle that allows climate stability. Why is there a way that we can answer the question, why do we even need an ice age cycle? Why couldn't God just create our world with the perfect climate that stays at the perfect climate without all of these ice age cycles and meteors and asteroids needing to strike the earth to make it a livable place? Why not just make it 75 degrees or whatever, obviously not 75 everywhere, but why not just create a nice climate for us to live? Why is this necessary?
Well, that could work if you're wanting to have a nice stable climate, say for 50 years or 100 years. But if you want a stable climate for 10,000 years, you need to find a source of water for the great agricultural plains if you want to be able to grow enough food to feed billions of human beings. I mean, what I put in the book, for example, if you look at the 20 greatest rivers of Asia, they all flow out of the Tibetan Plateau. They're all dependent on melting ice left over from the last ice age. I mean, to give you a biblical example, it tells us that there were four rivers that came together in the Garden of Eden. Two of those rivers, the Tigris and the Euphrates, are still flowing today. Why? Because they're fed by ice left over from the last ice age. But two of those rivers, the Gihon, the Pishon, no longer flow because ice left over from the last ice age has melted away. So they're dry riverbeds at this time. And the same thing's true here in North America. Our great rivers are flowing out of the ice left over in the Rocky Mountain Trench.
All right. So when it comes to then our response, a question here came in, and it says this: where do we draw the line between God's providence and our responsibility when it comes to managing climate change?
Well, in Genesis chapter 1 and in Job 37, 38, and 39, we have the command given to us by God. I'm putting you in charge of the resources of planet Earth. Manage those resources for your benefit and the benefit of all their life. And so we have this biblical mandate that we are stewards of the planet. You know, frankly, as a Christian, I don't want to be embarrassed when Jesus comes back and he says, "Boy, you sure trashed this place. You left me with a lot of work to clean up." No, it's kind of like the parable we see in the Gospels. I mean, God's going to say, "Okay, what did you do with the talents I gave you?" And so, on that basis alone, I think we, of all people, need to be responsible in the way we manage the planet, but also be aware, he said, "I want you to manage it for your benefit and the benefit of all their life," which means he's provided us with the resources where we can actually do both. It's not, people call my book the anti-Al Gore book, because Al Gore is telling us we have to make a choice between a rock and a hard place.
Yeah.
Basically saying, no, we don't have to make that choice. There are solutions where we benefit our own economy and technology. At the same time, we stabilize the climate and actually benefit the ecosystems of the world. And we actually make the planet a prettier place. I mean, I don't know
Yeah.
about you, but when I visit some of our national parks, I see clear signs of mismanagement. We could make those parks a lot more beautiful and enjoyable for the tourists, better for the wildlife there, and would actually enhance the economy of our nation.
Yeah, that's so good. And just for that reminder of, yes, God is in control, but we are still responsible for what he has given us stewardship and dominion over, and that is his creation. And what I love about reading your responses, which we'll get to here in just a moment, is kind of something I teach my students. That is, we often have these like dramatic, oh my goodness, we're overpopulated and we can't feed people, we need to do mass reduction of humans. It's like, no, through really good use of the skills and the knowledge and the wisdom that God has given us, we have different solutions that are a benefit to people and to our climate, which is what we'll get to here in just a moment. Question that came in on Instagram. I've heard this. Is this the one? Yep. I've heard this said that forest fires, that California right now is burning because of climate change. Do you have any thoughts on this?
Well, I would say that climate change is certainly a factor. The Western North America is warmer and drier than it's been in decades. So it is a factor explaining why we have these forest fires. Because if you have a warmer summer, that heat pulls moisture out of the ground and into the atmosphere. And so it is a factor, but I also argue it's not the predominant factor. I think the predominant factor is the way we've mismanaged our forests. And for example, I think we've been too aggressive in putting out natural forest fires. I mean, I've written in other books that it's crucial to maintain the health of the ecosystem that you have regular forest and grass fires. What that does is it puts charcoal into the soil. That charcoal conditions the soil, provides nutrients, and allows the soil to hold more water. And so there's a natural burn rate for every forest or brush area. Where I live here in Southern California, the natural rate for our chaparral is once every 8 years. The problem is we are very aggressive at putting out these fires. And so there's a really big fire not far from where I live, and it's burning in a place that hasn't burned off in a quarter of a century. And the problem there's way too much fuel. And so, and if we look at our national forests, we have laws that we forbid the lumbering companies from coming in. And I've walked through some of those forests. They're filled with a lot of dead wood,
Mm-hmm.
way too much dead wood. And we got way too many trees growing in these forests. The bark beetles come in,
Yep.
and in some of our national parks, a third of the trees are dead. We would be far wiser to let the lumbering companies come in and say, look, selectively lumber. We want you to cull out the old big trees that are in danger of dying and decaying. If we let them die and decay, that releases carbon dioxide to the atmosphere. That's going to enhance global warming. But if we harvest them early, then that can be sequestered as furniture in houses and not released to the atmosphere. Replace those old trees with young trees. Those young trees grow 2 to 4 times faster than the old trees, which means you're going to pull way more greenhouse gases out of the atmosphere. Make sure the forests don't get too thick with trees. That will stop the bark beetles. The trees can fight out the bark beetles on their own if they got enough water.
Hmm.
But if they have to share the water with too many other trees, then they all wind up getting infected. And if we don't have so much dead wood in the forest floor, the wildlife there is going to be able to maneuver through that forest more easily.
Hmm.
We tourists are going to see more wildlife. We're going to see a healthy forest. So we're going to want to visit our national parks more frequently because they're more beautiful and we
Yeah.
get closer to the wildlife. And again, you make more money. Now you're actually getting an income from these national forests and actually manage the fires in such a way that we return it back to the normal burn rate.
So this is something that just resonates so well with me because I was born and raised in Colorado, and I saw the beetle kill. And we would go up into Rocky Mountain National Park, and you see all these dead trees, and then the fires would come through and really clear them out, and you could see all the trees that had been burned up because they're already dead by a beetle kill. So this is one of your solutions you present in the book, is this idea of selectively cutting down trees based on these older trees. Are they producing more gases? Is that what it is, or they're not soaking up as many?
Well, they're not growing as fast. And
Okay.
because they don't grow as fast, they don't pull that much carbon dioxide out of the atmosphere. You want your forest to be predominantly inhabited by fast growing trees. And it's the older trees that are going to make you the most money because, I mean, they're nice and big. And so the lumber you get from them is going to be more valuable. But instead of clear cutting, you selectively cut. Cut out the trees, make sure you cut out the trees of the right species so you enhance the health of the forest. I mean, I think the Amazon is one big example. People are clear cutting the Amazon, trying to turn it into pasture land to raise cattle. They're unaware that the Amazon soil is so nutrient poor it can't sustain pasture land for more than about a decade. And once those nutrients have been saturated out, now you got a desert. We could literally transform the Amazon jungle into a desert. What we need to do is go to the Amazonian people and say, look, here's a way you can make even more money than you can make from ranching. Leave the jungle the way it is, and then selectively cut out the trees and replant the trees. And this way, you're going to have enhanced wildlife, which is going to give you another source of income because you can harvest some of those. Tourists are going to want to go there, and you're going to make a lot more income from the furniture because tropical woods have a very high value on the lumber market.
Okay. So if this makes a lot of sense, it makes more money, it reduces the gases, helps with climate change. Why is it not happening?
Because people don't know about these solutions. I mean, that
Are the
was,
scientists not out there saying, "Hey, look, here's a solution"?
well, it's in the published scientific literature. I mean, one of the things I'm trying to do in weathering climate change is basically alert you to the fact this stuff is already published.
Hmm.
It's published in reputable peer-reviewed journals. This is not something that's open for debate. It's an easy solution. We just simply need to get the right people to know about these things. That's one reason why I put in a web link to every research paper I cite,
Hmm.
which makes it easy for the reader to go straight to the paper
Yeah.
and see it for themselves. I mean, I'm hoping to actually influence some of the politicians that are trying to make some of these laws.
Well, I know most of the politicians watch my YouTube channel, so
Well,
Hopefully
there
we're
we
doing.
go.
I don't think I have that kind of influence. Okay, so next question came in here. So in terms of a timeline, how soon do we need to change things, and what do we need to change before it's too late? So how soon do things need to start happening?
Well, what I document in the book is that the global climate change models that have been put out by the IPCC, the United Nations Commission to Study and Research Climate Change, those models are off by about a factor of two. I mean, they are correct that the global mean temperature is rising quickly. Their newer models are a lot better. But yeah, a lot of people have been dismissive saying the old models exaggerated, but at best they only exaggerated by a factor of two. The climate is still warming. And so you got people out there saying we only got 10 years to turn things around. I think we got a little more time than that. But to wait until past 2050, I think would indeed be a disaster, because then
Okay.
it'd be impossible to stop the melting of the polar ice cap. And I'm also trying to communicate with my friends that are climatologists and saying it's a bad strategy to alarm the public. And so this alarmist attitude that, hey, we're facing Armageddon if we don't do things within the next 2 years, that's just going to make the public panic. And when people panic, they make the wrong decisions.
Hmm.
And especially politicians. Politicians, if you panic them, they're going to make the wrong decisions. So I got two chapters in the book on what I call unintended consequences of trying to do the right thing. So
Hmm.
you really want to study this thing well. And again, give people an economic motivation. If you give them an economic motivation, you don't have to crack a whip or pass some law saying you need to do this tomorrow. No, if I can see that I can invest $5,000 and get a return of 15%, I don't need a law. I'm going to go ahead and do it.
Yeah,
So,
absolutely. Well, and again, based on what you said at the beginning, a biblical principle is that humans are selfish, and so hey, if this is a benefit to you, it's easy to pass those things. Now, is it possible then, because human activity is increasing temperature and the natural system is decreasing currently, and so we're kind of at a balance? Is it possible that we could like perfectly balance this out and keep off the next ice age for a lot, many more years?
well, I argue that it can't be done indefinitely. And we wouldn't want to do it indefinitely, because if we do it indefinitely, we're going to run out of ice left over from the last ice age. And so, but I think it is perfectly reasonable that we can sustain climate stability for another 14 or 1500 years. And, for all those Christians that are premillennialists, they're going to want another 1,000 years.
Yes, exactly. So if we need an ice age for the water, and eventually our water will melt off from the last ice age, is it possible for us to survive another ice age? Or is once the ice age starts, kind of it's over for human civilization?
Well, once we drop into an ice age, number one, the temperature is going to drop very quickly. The climate's going to become unstable. We humans can survive, but our global high technology civilization that we're enjoying now, that will not survive.
Hmm.
If you got the global mean temperature jumping up and down by 12 degrees centigrade, it's simply not possible to have billions of human beings enjoying global civilization and travel. What you notice is during the last ice age, humans weren't traveling, they weren't building towns or transportation systems, mainly because they couldn't develop the surplus of food they needed. If you go into an ice age, your capability of producing food plummets. And for example, if you cool the planet, like what happens in a global ice age, uh, the carbon dioxide drops. And when you drop the carbon dioxide, food productivity. We're actually growing a little more food now because of the increased carbon dioxide. Because if you raise the carbon dioxide level up, plants will grow a little more rapidly. That actually peaks at about 600 parts per million. That's where you get the maximum food production. However, if you push it up to 600 parts per million, you will melt the polar ice cap. When that happens, you cool the planet, and then the carbon dioxide level will drop down to about 150 parts per million. And when that happens, food productivity plummets.
Wow. So interesting how just this interconnected system, right, of how everything has to be perfectly finely tuned, finely balanced in order for life to exist. And again, I think all the more reasons to believe in God and in a creator. So you've presented a few solutions, I guess. One with the trees, one solution of what we can do to not only boost world economy but also reduce climate change. The question came in here with one of the other solutions you mentioned in your book. The solution of replacing or replanting and expanding deserts intrigues me. This is what Susan writes, because I've never heard that solution by anyone else. It seems like such a win-win solution. Can you explain? So what is your solution as far as replanting and replacing kind of the deserts?
Well, we need to look at the deserts that we've made bigger by human abuse and activity. And the two most predominant examples are the Sahara Desert and the Gobi Desert. The Sahara Desert today is 10 times bigger than it was during the times of the Roman Empire. And the reason why is people living on the south edge of the Sahara Desert are stripping the land of vegetation for cooking fuel. So one of the solutions I propose in the book, let's give the sub-Saharan peoples all the kerosene they want. They can burn it as much as they please on the condition they work with the rest of us to replant the Sahara Desert. And that could be done in 20 to 30 years, where we get the Sahara Desert back to where it was during the times of the Roman Empire. Now you've got this huge chunk of North America that you can transform into growing grain. And you can sell that grain to all the food hungry nations of the world. That would give a source of income to all the North African peoples. That grain would soak up huge quantities of greenhouse, and then the ecosystem would be restored. A lot of the wildlife has basically vacated the Sahara Desert. That wildlife will come back if indeed we're able to replant the Sahara Desert. When you do a replant like that, you'll dramatically increase the rainfall, the natural rainfall that falls in that area. And we could do the same thing with the Gobi Desert, shrink it down to a quarter of its present size. And it's an example where everybody wins.
So I might have missed this as I was reading through some of the comments. How would you start the replanting process if it's a desert and you're not having, I guess, rainfall? I guess once it's planted, then natural rainfall will start. But how do you start the process in the beginning?
Well, the Israelis have already showed us how to do this because when they captured the Judean highlands, they were barren. And what they did is they began to plant trees, but they planted trees in concave bowls that they created, which means, yeah, you may only be getting 3 inches of rainfall, but all that rain is going to flow down the bowl towards the roots of the tree. And then trees transpire water back to the atmosphere. And so what they do is they plant trees distantly apart. As the rainfall increases, they plant the trees closer together. And if you go to Israel today, those barren Judean highlands are now healthy forests. And they did all that within a single generation. So we already have been demonstrated how to do it. We just need to do it on a much, much bigger scale.
Wow. Okay, so then what, as Christians, what do we, what should we now know or know now? And what should our message, our stance be? How do we then approach a very divided culture on this issue?
Well, I'm basically promoting we need to go to the general public, the influencers, the scientists, and the politicians with these win-win solutions. And what I tried to put in my book are the win-win solutions that can be instituted relatively quickly. And there's several that didn't make it into the book. I mean, I had to edit the book down. I mean, one that I wish I had kept in the book was the material I wrote on how we could pursue thorium nuclear reactors. Because right now there's a major push on nuclear fusion reactors, but the technological difficulties there are enormous, and never mind the huge expense. And yes, the public is very much against uranium nuclear reactors. Thorium is 3 times as abundant as uranium, and a 1 ton of thorium will deliver the electricity of 3,000 tons of uranium. And unlike uranium reactors, it's impossible for a thorium reactor to have a meltdown. it's also impossible to use those thorium reactors to make nuclear weapons. That's one reason why thorium was never produced back in the 1960s. We had the reactors, but they said we can't make weapons out of it. So
Hmm.
why bother? But today we're in a different situation. The fact that it's useless for making weapons is now considered an advantage. That means we can give these thorium nuclear reactors to all the nations of the world without any worry that they're going to use them to make weapons of mass destruction. It's simply not possible with thorium nuclear reactors, and you don't have the waste issue.
Hmm.
With uranium, you've got this toxic radioactive waste that
Yeah.
remains toxic for 50,000 years. With thorium, it's 200 years. And for most of it, it's only 50 years. And so trying to store the toxic waste for a 50 to 200 year period of time, and certainly within reason, we can find tectonically safe places to put it. And, uh, and then also mining it. If you mine the uranium, the high quality uranium ore, you've got to wear protective suits. That's not necessary with thorium.
Wow.
And there's enough thorium in the crust of the Earth to supply 100% of the world's energy needs for at least the next 1,000 years. And to me, what I find remarkable, if we scale up thorium nuclear reactors, we're going to have electricity and energy for less than half the price of what we pay for hydroelectric electricity, which today ranks as the cheapest source of energy on the
Hmm.
planet. And so we give people a source of energy that's cheaper than any other source of energy. We basically eliminate their motivation to burn coal, oil, and natural gas.
Wow. So, kind of going off of that, the question was asked: thorium is a form of uranium.
No, it's part of the periodic table, and so you'll see thorium on the periodic table. It's a heavy radioactive uh, element, just like uranium is, but it's much more abundant and much safer to handle, and it's very easy to use it to make breeder reactors, which explains why it's so much more efficient than uranium nuclear reactors.
Okay. Well, I just love this because it's, pointing out of the design not only in nature but also the knowledge and the creativity and just the things that God has given us to be able to create these advances to find new ways to continue to
Well,
improve and
here's a
be
mind
stewards.
blower, Ryan. We're living on a planet that's got 630 times as much uranium as any other probably existing rocky planet. We're sitting on the thorium champion of the universe. I don't think that's an accident. I think God purposely put us on this planet with a huge abundance of thorium. Number one, it provides us with our magnetic field. It provides us with the plate tectonics we need, but now it has the potential to provide us with all the energy we need without having to tap into fossil fuels.
So one question that came in is based on what's called the Green New Deal that I guess is being proposed right now. And I looked this up a little bit. Do you have any thoughts on this proposed deal? Is this going in the right direction, or what should we think about this?
Well, what's crucial for the Green New Deal, people haven't heard about it, it's the idea of the government passing laws to promote electrical generation by wind and by solar panels, and basically forcing the citizens of the world to go in that direction and stop using fossil fuels. The very fact that they got to pass laws that force people to go in that direction tells me we're going down the wrong path. You're not giving people an economic incentive, you're giving them a penalty,
Mm-hmm.
basically penalizing them for using any other source of energy. And I think it's flawed too in the fact that it's not taking into account how many fossil fuels you have to burn to sustain wind power. It's one thing all the electricity these wind turbines produce, but they got to be tuned to a particular wind velocity, and people don't realize how many birds they kill. And so I argue that solar panels is a better way to go than wind generation because you're not killing things.
Mm-hmm.
Although to scale it up to the necessary degree, that means you got to cover the deserts of the world with these solar panels, and that's going to ruin the desert ecosystem and could well create more deserts rather than less deserts. Again, unintended consequences. On the
Yeah.
other hand, I'm all excited about this new technology where you put a roof on your home, and the roof works as a roof and at the same time produces electricity. And instead of a third of your roof producing electricity, 100% of it produces electricity. And so, since we already got the roof covered, why not cover it with something that generates electricity? And there you're not impacting agricultural development, you're not impacting the ecosystem, and you're giving people an economic incentive. We don't need a law. And so
Hmm.
I'm saying we need to go down the pathway where we don't have to impose government laws or government penalties. Just give people an economic incentive.
Yeah, and I think that's the big key there is because oftentimes the laws that we try to create, as mentioned here in the live chat, other countries don't necessarily want to follow. And so simply trying to force them, you need to stop doing X or you need to start doing Y, doesn't often work. But if you say, hey, here's an incentive, who doesn't want that? As we've talked about here a few times.
Well,
Now,
people will cheat too. I mean, even here in America, you're going to get people who are going to cheat. They're going to have some kind of generator in their basement. And, if there's an accident, you burn down the house.
yeah, yeah. It was interesting too, as just east of us is Palm Springs from California, where all of the windmills are. And my wife and I, on our anniversary trip, actually out in Palm Springs, we went on the windmill tour, where they told us all about how these windmills work and why they generate and why they're spinning and why not. And I thought it was fascinating. But as you mentioned, that birds hit these things and it's killing birds, as well as I was at a birthday party, and a guy was telling me about how these uh, windmills or something are blowing up birds. And I went, what? And he found the video where it's actually all these mirrors that are used to reflect light into something and then harness the energy from the sun to create energy for us. But because all the mirrors are pointed at this one point to reflect all the energy from the sun there, as birds flew through the beam, you can literally see them blowing up midair. It was crazy.
Yeah, you'll see a place like that just east of Barstow. And so, fortunately, people realize that's probably not the best way to generate solar power. So, they're going with the panel idea. And better panels are coming because right now they're not economically valid. But I'm confident that within a few years, we're going to have roofing material that be just as cheap as the roofing material we have today, and it will generate all the electricity you need.
So I guess when I buy a house, instead of going to the people at Costco who keep trying to sell me solar panels, I just need to get a whole roof that is a solar panel, right?
Well, today, to have this special material where your whole roof generates electricity, it'll cost you twice as much money.
All right.
So the
Well, I'll
economic
hold off.
here yet, it could be scaled up where it would be cheaper than the solar panels. And
Yeah.
when that happens, anytime we need a new roof, you get the roof that generates electricity because it's going to be
Well,
the same price.
wonderful. All right. So, one thing I love about Reasons to Believe is that you use the scientific advances, the new discoveries to present reasons to believe in God. And we've talked a lot about that with the fine tuning and the way that this earth has this extreme climate stability that allows us to live and have civilization. And so, in the last moments that we have here together, how would you use the topic of climate change in conversations to point people to the truth of God and Christianity?
Well, it's a principle you draw up in the book of Acts. When the Apostle Paul went into Athens, he engaged these unbelieving philosophers with what? The text tells us with the latest ideas. And so he begins talking to them about things that they're already interested in. And I have found this subject of climate change and global warming, almost everybody you meet wants to talk about it. And if you got something rational to say about it, they're willing to listen. And a principle we've developed at Reasons to Believe is using the latest discoveries in the book of nature, the latest discoveries we see published at the frontiers of research science as a tool to bring people from the book of nature that God has given us to the book of scripture and then to the foot of the cross of Jesus Christ. I run into a lot of Christian evangelists who say we need to go straight to the resurrection. But my experience as an evangelist is there's a lot of non-Christians out there who don't want to engage me in a conversation on the resurrection. I need to engage them in something that they are interested in and give them a biblical Christian perspective on it, and then they're going to want to hear more. And so I use this as a bridge. I mean, we all heard about the bridge analogy in evangelism. This is another bridge analogy, and it's been my experience that it's easy to get a spiritually significant conversation going. Just the very fact, okay, when people realize that this climate stability that we have is a miraculous gift from God, then it begins to bring up other questions. Okay, why did God give us this?
Yeah.
What is the purpose? What is the purpose of humanity here?
Absolutely. Wow. Well, Dr. Ross, my goodness, thank you so much for your wisdom, for your scholarly research on this topic. The comments are coming in the live section about how many more people need to hear this, about how minds are blown. I know my mind is blown. I'm currently taking the astronomy and design class from the Reasons Institute, which is From Reasons to Believe. I would encourage that for the listeners. If you're interested in learning more on science and faith, the Reasons Institute is wonderful. I think I'm in my 4th class right now. And so I was joking with you beforehand as I've been watching all of your lectures for that class the last 5 weeks. And now I finally get you live where I get to talk to you, and how wonderful that is. So Dr. Ross, thank you so much for this time that you've shared with us, for this wonderful knowledge and research. I so much appreciate it.
Well, you're very welcome. I appreciate the opportunity.
Absolutely. Guys, thank you so much for watching. I hope that you have enjoyed this, that you are encouraged by it. If you have benefited, please share it with those around you so that they can hear this wonderful news as well, and how to respond as Christians in this culture. This is a weekly show. Next week on Monday afternoon, I think at 4:30 p.m. Pacific time, Elisa Childers is going to come on to talk about progressive Christianity and people trying to bring a new gospel and how we can respond to that. So that's going to be a fun conversation in just a few days away. So thank you so much for watching. As always, some videos will pop up in the corners if you're watching this after the fact, and come back next week for more. Keep thinking deeply about Christianity. See you guys. Have a wonderful rest of your day. God bless.